All right, class. In this video, we cover example 4 on page 3 of your section 4.1 lecture handout on exponential functions. And so here on page 3 in example 4, we are going to graph an exponential function. We're going to graph the exponential function f of x equals 3 to the x. Now we have studied the graphing of functions earlier in the semester. And so I'm just going to pull up here briefly your lecture notes from your lecture handout from section 2.2 back in late February on the graphs of functions. So in section 2.2, right, we learned how to graph a function in the coordinate plane. And remember, it's like there are it's the same basic steps over and over when you're graphing a function by hand. First, you need a table of values, right? You need to select some values of x, and then you need to calculate the corresponding function values, or the values of y. Remember, y values and function values are the same. And then for each value of x and each value of y, you form the ordered pair xy, and that's a point in the coordinate plane. And then you take those points in the coordinate plane and you plot those points in the coordinate plane. And then after you plot the points, you play connect the dots. And so that's what we're going to do now in graphing the exponential function f of x equals 3 to the x. So down below here, I have my table of values, right? My values of x are -2, -1, 0, 1, and 2. And then for each value of x, I got to calculate the corresponding value of y, which is the same as the function value at each value of x. And then for each x and y, we form the ordered pair, and then we're going to plot those points and play connect the dots. And so we know how to evaluate an exponential function at different values of x. We did that in the previous video. So when x is equal to -2, y is equal to 1/9 or 0.111. And so the ordered pair, or the point -2, 0.111, is a point on the graph of our exponential function f of x equals 3 to the x. When x is equal to -1, y is equal to 1/3 or 0.333. So -1.333 is a point on the graph of our function. When x is equal to 0, y is equal to 1. And so 0, 1 is on the graph. And when x is equal to 1, y is equal to 3. So the 0.13 is on the graph. And when x is equal to 2, y is equal to 9. And so the 0.29 is on the graph. So we got our 5 ordered pairs, right? Our 5 points. And now we plot those points in the coordinate plane down below. And you can see, right, here's 1 point, here's a second point, the third point, the fourth point, the fifth point, excuse me, plotted in the coordinate plane. And you can see, right, this is the graph of the exponential function 3 to the x. Now it looks like the graph ends up here, but that's not really the case. It really keeps on going, right? It keeps going up forever. And on the left over here, right, you can see it's, as we go out here on the left, the graph is starting to flatten out, and the graph keeps going out here to the left forever. And it flattens out above the x-axis. It never crosses the x-axis, never touches the x-axis, but it flattens out going to the left, getting closer and closer to the x-axis without crossing or touching it. That makes the x-axis a horizontal asymptote. And the horizontal line, y equals 0, coincides with the x-axis. So technically speaking, the equation of the horizontal asymptote for this function is y equals 0. Now this is a good time to talk about exponential functions with the coronavirus outbreak. You may have heard in the media that the number of people being diagnosed with the coronavirus is growing exponentially. And you can see that as x gets larger, the value of y is increasing much faster. That's what they mean by exponential growth. And so, you know, if X is days, you can see, and Y is the number of those diagnosed with coronavirus. As the number of days increases, the number of those diagnosed with coronavirus is growing quite rapidly. That's what we mean. That's an illustration of exponential growth.